If a tangent line is horizontal, what can you say about the line?
The slope isn't very steep.
What's the value? Do you know what the value of the slope is if it's horizontal?
It's 0.
So the slope of the line is equal to 0. And how do you find the slope of a tangent line again?
You find the derivative.
Okay, yeah. So then what's it asking us? What expression can you set up then if you want the slope to be 0?
The derivative of f, so f like f prime,
So then what do you want the derivative to be?
it equals 0.
Yeah. Because when the derivative equals 0, then the slope of the tangent line is 0, which means the tangent
Okay,
line is
yeah.
horizontal.
Okay, yeah, I get it.
Okay. Do you remember how to deal with square roots?
Don't you, like, put the actual thing in, like, parentheses and put it to, like, the 1/2?
Yeah, exactly. Because there's no rule for square roots. So you have to rewrite as an exponent so that you can use the power rule. If we rewrite the function, what's it going to look like?
So x to the third minus 9x squared plus 24x plus 6
Okay. And what else?
out to the 1/2.
Okay. Okay. And then do you know when finding the derivative, do you know what rule you have to use for this?
I don't remember what the rule's called, but it was like the power rule.
That's part of it, but what's the overall rule?
I don't know what you're asking.
So notice that we can think of this as a function, right? This polynomial, and then we apply a 1/2 exponent to it, which is another function. So do you see how this is like a function that's plugged into a function?
Yeah,
So, or a composite function. So do you know what rule you have to apply when you have a function within a function?
but the chain one?
Yeah, chain rule, right? Do you know how chain rule works?
Don't you, like, take the original one and times it by the derivative of it?
You can think of it as you find the outer derivative and multiply it by the inner derivative. Notice that the 1/2 exponent is the outer function, right? Because it's on the
Yeah.
outside of it's being applied to whatever this is. So what's the derivative rule for having exponent of 1/2?
Don't you put it in the beginning?
Yeah, so you have 1/2, and then what would you do to the exponent?
Oh, minus it by 1.
Yeah, so what would the new exponent be?
Negative 1/2.
Yeah. And do you know what you apply that derivative rule to?
The derivative of the x to the third minus 9x squared.
So that's the second part. But the idea is that outside derivative, you find the outer derivative, but you still maintain the inner function. So this thing is still the
You haven't
same
changed it
here.
yet?
Yeah. So the idea is you only apply one derivative rule at a time.
Okay.
So we just applied the rule for the 1/2 for the power rule. So that means that everything else has to stay the same.
Okay.
Now we multiply by the derivative of the inner function, which is this thing. So you kind of go layer by
Okay.
layer.
Okay, I get it. Okay, so
So
then
then,
3x squared minus 18x plus 24.
okay.
And is that whole thing what we use to equal to the 0?
Yeah, exactly. One derivative equals 0.
And then what?
Now we have to solve for x.
Oh gosh, okay.
Yeah, this one, if you rewrite it, you'll see that it's actually not too difficult. So how do you rewrite this with the negative 1/2 power? What's that going to look like?
It's gonna go, like, into a fraction.
There's a negative exponent being applied to this. So then where does it go?
Oh, the denominators are
Okay. So yeah, what's the overall denominator?
the x to the third minus 9x squared plus 24x plus 6
To the what power?
1/2.
Yeah. Okay. And then let's throw that 2 in there as well in the denominator. And then
And
what goes in the numerator?
what do you mean?
You see this part here? Where does that
Oh,
go?
wouldn't that be a separate one though, like a separate fraction?
This goes in the denominator. So then this is, you can think of 1 multiplied by this. So then if you multiply these, where does this go?
Oh, okay, so okay, I get it. So that goes on the numerator. You just
So now if you look at it this way, how would you solve then?
you start with the bottom first.
Well, notice it's equal to the other side is 0, right? So how can you like get rid of the fraction? Typically, when you're trying to simplify, you want to get rid of the denominator, right? So what do you do to both sides to get rid of the denominator?
Multiply it by the denominator.
Yeah, you can multiply both sides by the denominator, which works out nicely because the other side's 0. So what's going to happen?
They're gonna cancel out.
Yeah, so what's left over?
The 3x squared.
Yeah, it's just going to be that part equals 0, right? And that should make sense because 0 over anything is going to equal 0, right? So if you have a fraction that's equal to 0, the denominator is not relevant. You might have to check and make sure you don't have a 0 over 0 case, but let's just solve this for now. So we can multiply the denominator of both sides, which gets rid of this denominator on one side, and the 0 stays 0, right? So then
Mhm.
how do you solve this equation?
And you factor.
Okay.
So it's 3 times x minus 4 and x minus 2.
Let me see. Okay, x squared minus 6x plus 8. Okay.
Then x equals 4 and 2.
Okay. Okay, yeah. All right. So these are the values of x, which will give you a derivative of 0. And a derivative of 0 means that the slope of the tangent line is 0 at those points, which means that the tangent line is horizontal.
Okay.
Does that make sense?
Yeah.